So as we look at the second part of section 3.2, a couple things we want to do. First thing is we want to go backwards. We want to be able to find a parabola that's going to fit a particular curve. So take a look at the example. Find the equation of the quadratic function with the vertex passing of 2, -3, passing through the point 869. Now, notice that they'd like us to express this answer not in vertex form, but in standard form. So, a couple things. I need you to notice that 869 will be above 2, -3. Because notice that the 69 is greater than -3. That means that the parabola opens up and A will be greater than 0. So the first step we're going to do is we're going to start with vertex form. Our vertex form being that y equals a times the quantity x minus h squared plus k. Well, if you go back here, your vertex gives you the h and the k, and the point that you pass this through gives you the x and the y. So we're going to substitute all that in. 69 is y, a we don't know, x is 8, h is 2, and k is -3. And then our step, well, we're going to solve for a. So we're going to simplify 8 minus 2 in the parentheses gives me 6, and 6 squared gives me 36. That's 36a minus 3. Adding our 3 to this side gives us 72 equals 36a. And thus we get that 2 equals a. Remember I said back in step 1, notice that the point that we pass through is above the vertex. That means that this is in fact going to be a positive number for a, which we found. Step 3, we're going to write the equation in vertex form. So we have y equals 2 times x minus 2 squared minus 3. Then as our final step, we're going to rewrite to standard. So the first thing we have to do, let me change colors here, is we have to take x minus 2 and square it. So that's x minus 2 times x minus 2, which if we FOIL this out, we get x squared minus 4x plus 4. So back to our problem, I'm going to replace the x minus 2 squared with x squared minus 4x plus 4. Then we'll go ahead and distribute the 2 through. And our final simplification, combining the 8 minus 3, and we get the answer of y equals 2x squared minus 8x plus 5. And again, once you get this, pop it into Desmos to see if, in fact, this equation in standard form has the vertex of 2, -3, and it passes through 869. Now, the second thing that's important for us is that we talk about a circle. Remember that a circle is the set of all points in a plane, each of which is an equal distance r from a fixed point, hk, the center of the circle. The point hk is the center of the circle, and the distance, the r, is the radius. So that means that we can use the distance formula to help us derive an equation of a circle with a center of hk and a radius of r. And if you recall the distance formula from previous work in Algebra 1 and geometry, is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Remember, the distance formula came from the Pythagorean theorem. A squared plus b squared equals c squared. So for us, this distance that we're talking about, because we're talking about a circle, that has that fixed center point someplace at HK, and every one of the points on the circle would be the x and the y. And that distance, well, we don't call it distance, we call it radius. So the radius would equal the square root. Instead of x2, I'm going to replace that with just x. The center coordinate is h. Y sub 2 gets replaced with just y. Now, since we really don't want to deal with the square root, we're going to go ahead and square both sides. And thus we get the center radius form of a circle. X minus h squared plus y minus k squared equals r squared, which you can see is known as the center radius form of the equation of a circle. The center is at hk and the radius is at r. So you'll get things that'll look something like this. X minus 3 squared plus y minus 5 squared equals 36. Would have a center at 3, 5, and the radius would be 6. Now, just like we've done before, whenever we have that thing inside the parentheses, we always have to take the opposite. So if I had x plus 4 squared, say plus y minus 1 squared equals 16, then the center would be at negative 4, 1, and the radius would be 4, because 4 squared does equal 16. But sometimes we're not given center radius form, we're given the general form. X squared plus y squared plus cx plus dy plus e equals 0. By looking at this equation, it's hard to determine the center and the radius, because it's not there like it is in center radius form. So we are going to change this, and the way we're going to change it is just like we changed for a parabola. We're going to do completing the square. So take a look at my example. X squared plus y squared plus 2x plus 6y minus 15 equals 0. And we would like to rewrite this to be x minus h squared plus y minus k squared equals r squared. Well, we're dealing with the binomials just like we were before. So the first step is we're going to rearrange. We're going to put our x terms together. We're going to put our y terms together. And we're going to move that 15 to the opposite side. Step 2, just like we did with parabolas, we're going to complete the square. So for our x's, we're going to take 2 over 2 and square it. That gives us 1. For the y's, we're going to take 6 over 2 and square it. That gives us 9. Notice that I'm adding 1 to both sides and adding 9 to both sides. Go back to my red. Step 3, we're going to factor and simplify. So factoring x squared plus 2x plus 1, the factors that multiply to 1 and add to 2 are x plus 1 times x plus 1, or x plus 1 squared. And again, notice how this factor is always half of what the b value is. For the y's, 3 times 3 is 9, 3 plus 3 is 6, and again, half of 6 is 3. Simplifying over here, 15 plus 1 plus 9 makes 25. And now we're ready to state what the center and the radius are. The center being the opposite of what's in the parentheses, so that's negative 1, negative 3. And our radius is 5. So I believe when you graph these on MATLAB, if I quickly just sketch in a coordinate plane system, Here's -1, -3. Plot that center point. Remember, the radius is 5, so that means we can go 5 in any direction that we wish. So we're going to go 5. In this case, I'll just go 5 out horizontally. So here's the center at -1, 3. Adding 5 to get my horizontal gives me 4, -3. And then I can simply draw a circle. Going all the way around. And that is how we find the center radius equation of a circle.